Hey devs, welcome back. Today I'm going to show you how to add some serious style to your projects. We are talking custom fonts that look amazing, colors that work beautifully together, dark mode that's smooth as butter, and a theming system that will make your apps feel truly professional. Oh, and there's this one thing about Modifier Order that's going to save you from frustrating debugging hours later. By the time we are done here, your app's going to go from good to absolutely stunning. So grab whatever keeps you caffeinated and let's make your app shine. Alright, let's talk fonts. Look, SF Pro is fine and all, but after a while, your designer is gonna start giving you those looks. Whether you're building something fun for kids or trying to look all fancy for a banking app, custom fonts are what give your app personality. I'm gonna show you how to get them working without wanting to throw your laptop out the window. The process seems simple enough, but there are some gotchas that will bite you if you're not careful. Let me walk you through it so you don't have to learn this stuff the hard way like I did. Okay, so first thing, you gotta get your font files into the project. Drag your TTF or OTF files into Xcode and make sure they end up in copy bundle resources in your build phases. Don't skip this part or you'll be scratching your head later. Next, you tell iOS about them by adding this to your info in project settings. If you already have an info.place file in your project navigator, you don't need to go in project settings, just jump to what I'm adding in your info.place file. So in project settings, select your target, then the info tab, and here we add fonts provided by application. Inside it, add a font file name. You can copy the file name as it is, make sure you copy the extension as well. Now here's the thing that's gonna mess with you, and I wish someone had told me this earlier. The font name you use in SwiftUI's dot custom thing isn't always the file name. You need the PostScript name from inside the font file. Yeah, I know it's weird. Here's how you figure it out. First, you can install the font in your Mac if you haven't. So I've already installed it and you can install it by double clicking the font and hitting the install button. Next, open font book and find your font in my fonts tab and open it. Now we click on the info button and there it is, the PostScript name inside identifiers. We need to use this name exactly as shown in our code. If you get this wrong, your custom fonts just won't show up and SwiftUI will silently use the system font instead. So once you have got your fonts registered, using them is pretty straightforward. But hold up, this approach has a problem. It totally ignores accessibility. When someone cranks up this font size because they need bigger text, your fixed size fonts are just gonna sit there being stubborn. The fix is relative to parameter. So what's happening here? The relative to parameter tells SwiftUI which text style your font should scale with. You can pick from several options like large title, body, caption. So when someone bumps up their text size in settings, SwiftUI does the math and scales your custom font proportionally. This means your 20-point font grows and shrinks based on what the user actually wants to see. Your app stays accessible and you still get to keep your fancy custom fonts. Win-win. One thing to note here though is using the right font type. Font with regular type won't have a good effect on all relative types. Also, let me show you one trick in Xcode that will save you hours on loading previews. You can click this button and test multiple variants of your previews like light and dark mode as well as multiple orientations and dynamic text. This is the best way to check your UI. Don't try to add a bunch of hash preview unnecessarily. You can also test this stuff this way. Click here and turn on dynamic type and let's scale it to max. See how relative to helps us scale our text differently for each type even though they have the exact font size. That's the power of Swift UI previews. Okay, so let's get back to our font. I'll tell you one thing, writing dot custom everywhere is gonna get old real fast. Plus, when you want to change something later, you'll be hunting down every single instance like you're playing the world's most boring game of Where's Waldo. Here's a much better way, make a font extension. And then all you need to do is use dot heading directly instead of typing all the dot custom blabber. This is so much better because everything is in one place. Change your font size once, it updates everywhere. It actually makes sense. Dot heading tells you way more than some random size number. You also get easy updates. Your designer wants to try a different font, change it once and you're done. It also matches how designers think. They work with type scales, not random font sizes. I had installed a MP3 player in my Windows machine which allowed me to set different color themes. All your fonts automatically scale with user preferences. Most professional apps have like 4 to 6 of these font styles set up. It keeps everything consistent and makes your life way easier. Alright, you have got your fonts looking good. Now let's talk colors. Maybe you want something bright and fun, maybe you're going for the dark, mysterious vibe, or maybe you want to let users switch themes on the fly. SwiftUI has got you covered and it's actually pretty awesome once you know the tricks. Asset catalogs are honestly amazing for this stuff. They make color management super easy and they basically solve dark mode for you before you even realize you had a problem. So asset catalogs are basically Apple's way of saying, hey, we figured it out how to make this not suck. They handle light mode and dark mode automatically and work with both SwiftUI and UIKit. Here's what you do. Open assets.exe assets in your project, hit the plus and pick color set. Give it a name that actually makes sense like brand primary or card background. Click on the color and set appearances for the options available. Pick different colors for each mode. Here's the super important part. Don't name your colors like light gray or sky blue. That's gonna bite you later. Use names that describe what the color is for. For example, button background, primary text, card surface, accent color, or error text. So that when your designer decides that blue should actually be green and they will, you just change it in one place instead of hunting down every blue 64 reference in your code. Plus, when you're reading code later, button background tells you way more than some random color name. Think of these as design tokens. They are not specific colors, they are roles that color plays in your interface. Once you have defined colors in your asset catalog, SwiftUI makes them available through the color initializer that takes a string name. The cool part happens automatically. SwiftUI checks the current appearance, light or dark mode, and uses the appropriate color variant from your asset catalog. Few things important to note: if SwiftUI can't find a color with the specified name, it falls back to a default color, usually clear or black. This silent fallback can mask typos in color names. So always double check your asset catalog names match your code exactly. Color lookups by string name are cached by iOS, so there's no performance penalty for using color with color background value multiple times throughout your app. SwiftUI provides several adaptive system colors that automatically adjust to light or dark mode and respect user accessibility preferences. There are some advantages to using system colors. Dot primary and dot secondary automatically provides appropriate contrast ratios. Dot background adapts to the current color scheme. All system color respect accessibility settings like increase contrast. So how do we decide which approach to use? You can use system colors for standard UI elements, body text, labels, backgrounds, dividers. You can use custom colors for branding, logos, accent colors, brand specific highlights. Or you can use mixed approach, create apps that feel native while maintaining brand identity. Now, how do we get fancy and support multiple themes like light and dark, but also maybe unicorn mode or hacker mode? With a little bit of setup, SwiftUI makes this surprisingly straightforward. No weird hacks, no messy singleton patterns, just clean code that actually makes sense. Building a custom theming system starts with defining a data structure that holds all your design values. This creates a single source of truth for your app's visual identity. You can extend this pattern to include button styles, spacing scales, typography systems, and even animation durations. White label apps often define multiple themes properties to cover all visual aspects consistently. And the same can be used to define different themes. So SwiftUI's environment system provides a clean way to inject themes throughout your app without prop drilling or singleton patterns. This creates a custom environment key that any view can access. The default value ensures your app has a fallback theme even if none is explicitly set. Now, any view can access the current theme through the environment. Here are some benefits of using environment. We get automatic propagation. Child views inherit parents' themes automatically. We get performance. SwiftUI only re-render views when the used environment values change. We also get testability, easy to inject different themes for testing and previews. And finally, we get clean architecture. No global state or singleton dependencies. So how does it work? SwiftUI maintains an environment dictionary that flows down the view hierarchy. When you set an environment value, all child views have access to it through the environment property wrapper. To enable runtime theme switching, wrap your theme state in at observable that publishes changes to the SwiftUI system. The at observable makes all of its properties automatically trigger view updates whenever the theme changes. This is SwiftUI's reactive programming model at work. You can also wire it in your app's root scene. Here are some key architecture points you should keep in mind. First, the add state creates and owns the theme view model instance for the app's lifetime. Second, environment injection makes the current theme available to all child views. Third, environment provides access to the theme switching functionality. The last, reactive updates when current theme changes, all views using the theme automatically re-render. You might also want to persist theme selection to user defaults and restore it on app launch, or fetch available themes from a server for dynamic branding. At this point, you have got fonts, colors, dark mode, and themes dialed in. But let me sprinkle in some bonus SwiftUI styling tricks that will make your app feel less like a prototype and more like something you'd actually want to ship. Level up your basic styling with proper shadows and corners. This adds subtle elevation and makes elements feel touchable, essential for cards, buttons, and modals. Pro tip, avoid full black shadows, use opacity plus blur for natural depth. Now let's talk about buttons. The default SwiftUI button is okay, it gets the job done, but it's not exactly gonna win any design awards. SwiftUI gives you some built-in styles that are way better than the basic button. Plus, you can create completely custom styles that match your app's personality. The cool thing about SwiftUI's button styling system is that it's reusable and consistent. Once you define a style, you can use it everywhere in your app, and if you need to change the look later, you update it in one place. You can apply it like this. The configuration parameter is where things get interesting. It tells you whether the button is currently being pressed, disabled, or in other states. You can use this to create different visual effects based on user interaction. That scale effect with the press animation makes the button feel responsive and alive. These little micro interactions are what separates good apps from great apps. Users might not consciously notice them, but they definitely feel the difference. Now let's be honest, the default text field in SwiftUI looks pretty basic. It's just text on a transparent background and it doesn't exactly scream professional app. But with a little styling love, you can transform it into something that actually looks like it belongs in a modern app. The key is treating text fields like any other UI component. They need visual hierarchy, clear boundaries, and states that user can understand. A well-styled text field should clearly communicate when it's focused, what type of input is expected, and whether there are any validation errors. This approach gives you a text field that looks intentional and polished. The padding creates breathing room, the background provides a clear input area, and the border overlay defines the boundaries. You can theme this input styling using your app theme too, so all your text fields stay consistent throughout the app. Pro tip, you can extend this pattern to handle focus states, error states, and different input types. Create different variants for search bars, password fields, or multi-line text areas. Now, reusable view modifiers is where things get really smart. If you find yourself copying and pasting the same styling code over and over, stop. You're doing it wrong. SwiftUI's view modifier protocol lets you package up common styling patterns into reusable components that makes your app code cleaner and your design more consistent. Think of view modifiers as your own personal styling toolkit. Instead of remembering exactly which padding, corner radius, and shadow values to use for cards, you just apply dot card style with parentheses and you're done. When your designer inevitably wants to tweak the card appearance, you change it in one place and it updates everywhere. This pattern is incredibly powerful because it enforces design consistency while keeping your view code readable. You can create modifiers for common patterns like primary button, section header, or error state. Your future self will thank you when you need to update the design system across your entire app. Now let's look at modifier orders. In SwiftUI, the order of view modifiers isn't just a nice to have, it's actually crucial for getting the results you want. Apply them in the wrong order and your layout might go from beautifully styled to why is this button not working properly. Let me show you how modifier sequencing affects everything from shadows to tap areas, because this will save you so much debugging time. Now in this example, the yellow background hugs the text tightly and padding is added outside. Now let's flip it. The padding expands the frame first, so the yellow background wraps the whole padded space, giving you a pill style appearance. Not exactly a pill style since we are not using corner radius. Let's look at one of the most common mistakes I have seen devs making, and I totally get why. You're trying to create a nice button with a shadow, but the shadow either barely shows up or appears in the wrong place. The culprit, modifier order, strikes again. Here's what happens when you get it wrong. What's happening here is that SwiftUI applies the shadow to just the text element first, then adds the green background after. So you end up with a barely visible shadow on the text itself while the green background sits there with no shadow at all. The visual result looks disconnected and amateurish. Here's how you can fix it. Apply the shadow after you have built up your complete button appearance. Now the shadow applies to the entire rounded green background as intended. The sequence matters because SwiftUI builds your view layer by layer. First, the text gets the padding, then that padded text gets a green background, then that background gets rounded corners, and finally, the whole thing gets a shadow. Think of it this way: you're building your button from the inside out, and shadows are always the final layer that wraps around everything else. Now, this one is super sneaky and will definitely catch you off guard. You create what looks like a perfectly clickable button with a nice background color, but then users start complaining that your buttons are hard to tap. The problem? The visual appearance doesn't match the actual tappable area. This looks like a normal blue button, but here's the problem. Even though you see a blue background, only the text itself is actually tappable. The blue area around the text is just decoration. It's not part of the button's interactive region. So users see a big blue rectangle but can only tap on the tiny text area in the middle. This is especially frustrating on mobile devices where precise tapping is already challenging. Users will tap what looks like a button and nothing happens, leading to confusion and a poor user experience. Here's the proper way to create a button with the correct tap target. Now the magic happens by putting the padding inside the button's label closure. You are expanding the button's content area before applying the background. This means the entire blue rectangle becomes tappable, not just the text. The key principle here is that in SwiftUI, the button's tappable area is determined by its content, not by decorative modifiers applied afterward. Always build your interactive area first, then style it. Now, here's the rule of thumb that I want you to remember: the golden modifier sequence. Code layout first, like padding, frame, alignment, offset. Style next, background, corner radius, shadow, border. Behavior last, on tap gesture, transition, animation, accessibility. Knowing this one principle can save you a lot of time debugging layout issues. Trust me on this one. And there you have it. Your app just went from looking like a prototype to something you'd actually want to show people. We covered a ton of ground here: custom fonts that scale properly, colors that make sense and adapt automatically, dark mode that just works, a theming system that will make you look like a pro, some styling tricks that add real polish, and that modifier order thing that's gonna save you so much debugging time. With these tools in your back pocket, you can take any boring gray app and turn it into something that actually looks and feels great to use. Plus, your code stays clean and maintainable, which future you will definitely appreciate. If you want to keep learning the stuff and build apps that people actually enjoy using, hit that subscribe button, and while you are at it, hit that bell icon as well. I'm always dropping new tutorials that dive deep into the advanced SwiftUI techniques that actually matter. Check out the SwiftUI Mastery Series playlist if you want the full journey from beginner to someone who actually knows what they are doing. Links in the description. Thanks for hanging out with me, and I'll catch you in the next one. Now go make something awesome.